Everybody have that? Have that packet? Everyone have? You need it? You need it? You need it? I think I can find it. I think I can. I think I can. I think I can. I think I can. Yes. It's from the other day. You do? You got it? Common loop. Yep. Catch it. Got it? Got it? Got it? Gotcha. All right, let's take a look at this problem. So 1, 2, 3, -3, -3. That point there is -2, -1. That point there is 1, -1. 2, 1, 2, 2, -4. And 1, 2, 3, 4. Okay, so the big things that we're worried about on this problem: domain, range, max, min, increasing, decreasing, constant. Don't worry about the 8, 9, 10. Cool? All right, so my domain, it's from here to here. So -3, 4. We could make them square brackets, something like that. Range. Range is from here all the way to here, so -4 to 4. And then a maximum value. Maximum value is right here. So just label it as the point for right now. That is incorrect, but for right now, we're totally fine. Deal? Minimum value is right here. Oh, you got done. Thanks for coming in, kid. Thanks, Ella. All right, and then let's see. What was the next one? Increasing. So it's in because the domain is the furthest left x to the furthest right x. And the range is the furthest down y to the highest up y. So increasing. This is increasing in 2 different spots. Is it okay that a graph increases in 2 spots? Sure. So it's going to increase from -3 to -2. And it's also going to go from 2 to 4. Okay? So these here, this is not the point. This is what they use the language for increasing. So from -3, this -3 to this -2 is the first one. And then from this 2 to this 4 is that one. All right, let's see. Orange. Decreasing. Decreasing is just here. So 1 to 2. And then constant. Constant. Nice pink. Constant. That's when it's this. That's constant. So from -2 to 1. That's all you have to do. Seem okay? Okay, so that packet, we are going to come back to it, but put it away for right now. But we'll come back to it. Do not toss it. We'll come back to it. Deal? Make sense? All right. So this is, we're adding a little bit more to our foundation and stuff. They better come back with ice cream for everybody.
Thank you.
this little worksheet. Now we're gonna come back to that other packet, so do not get rid of that, please. We will be coming back to it. All right. So this problem up here says Alonzo, Maria, and Sierra were floating in inner tubes down a river enjoying the day. Okay. Might be a little cold to do that today, huh? Alonzo noticed that sometimes the water was much deeper in some places than in others. Maria noticed there were times that they seemed to be moving faster than at other times. To learn more about the river, they collected data throughout their trip. Alonzo's graph, pictured below, shows the depth of the water as they floated along. Next, Maria created a graph collected on a GPS unit to provide the distance she had traveled over a period of time. So these two different graphs are representing two different things, but they're talking about the river. Yeah. Nada. Here.
Oh, okay.
But not yet.
Okay.
All right. So if we take a look at this first graph, I'm going to just kind of draw a rough sketch of it. Okay. And this was time and feet. Feet deep. How deep the river is. And then the other graph looks something like this. Something like that. And this was time and distance. And of course, we have a XY axis and an XY axis. Okay. So, two graphs using the same river to represent two different things. Time is the same between the two, time in minutes. One of them is measuring how deep the river gets, and one of them is measuring how far was actually traveled on the tube. So this is an entire distance. So whatever that point up there is might mean something. But then this talks about just how deep the river is as they're floating down the river. Seems kind of a. Let's see what kind of trouble we can get into from here. Okay. So this is the first graph is Alonzo's graph. So we want to do the domain. So from here to here is what took place. So this started at 0, and this went to, I can't see that, 120. So notice I'm not listing the whole point. I'm just going to list the domain. The domain happened to represent time. Time is in the x direction. Okay. What else can we say about this? We could say about the range. Okay, the range goes from our lowest y value, so it's here and here, which appears to be, this is 4 in the y direction and this is 4 in the y direction. Okay, so and then our maximum depth is all the way up here, and I'm just using, is that 12? Is it 11? 11. Oh, I think it's 12. I think it's 12. Unless my eyes are playing tricks on me. Okay, so the range goes from 4 to 12. Okay, so the river goes 4 feet deep to 12 feet deep, anywhere in between. Thought you were getting a computer. Oh, you guys were gone for an extended period of time.
Yeah, you're with Dean House. She was trying to help us find it.
Oh, that was nice for her. All right, we're working on that little worksheet that is on your desk. We just kind of started it. All right.
So sorry to interrupt you. Can I see you for just a quick second?
Yeah. All right. So, hey guys, I love that you're borrowing my pencils. I don't need to find them on the floor after class. Put them either back or take them with you. Deal? All right. Maximum. Okay. This is the maximum point. Agree? So that appears to be 70, 80, 90, 90 comma. So the max is taking place at 90 comma 12. Does that make sense? Now again, hey, so the minimum and maximum, we're listing them as a point. That's actually incorrect, but it's totally correct right now. Okay? We'll be able to correct it later, but I think it's visually easier to do. And then a minimum value happened in here, and it happened here. What do you think? So here and here. So it happened at 0.4, and it also happened at 60. So that 60 was the time, right? 60 minutes in, it went back to being 4 feet deep. Okay. Now let's try and figure out increasing. So it's increasing here. It's also increasing here. So that entire region. So it's increasing from 0 all the way to here, which is 10, 20, 30. It's increasing from 0 to 30. And then it's also increasing here. Now this kind of changes direction a little bit, but it's still increasing the whole time. So that's going from 60 to 90. Okay, and again, remember, I'm only using the x values. So I didn't necessarily write down all the points. I'm just kind of basing off of what I'm looking at. Decreasing. So it's decreasing here. And decreasing here. Okay, so that's 30 to 60. And also decreasing from 90 to 120. Now, this is a perfect time to talk about something for a minute. I want you to notice this. And I want you to notice this. Those 60s are the same number, right? That 60 is right here. Agree? So, we don't have to know this yet, but it's a perfect time just to take a little inkling of a moment to just discuss why I'm using parentheses. So when you use a parenthesis when you're talking about increasing, decreasing, if you use a parenthesis, which a lot of times they will refer to that as a soft bracket, that means that the point is not included.
Excuse me. Can I have a really follow?
Yeah. So here's a parenthesis here. Here's a parenthesis here. That means they're soft. They are soft brackets on that, meaning that point can be used twice because I go up to it, not quite to it, and not quite from it, up. So that means that's something that's a big idea to see. We're not quite there to understand completely why that's taking place. And then x-intercept, is it crossing this x-axis ever? Is this graph crossing this x-axis here? Does it ever cross right here? No. Okay, so x-intercept. I have to write it up here because I ran out of room. The official math term, nope. What? the y-intercept. Does it touch my y-intercept right there? Sure does. So that's the y-intercept is at 0, 4. Okay? There you go. Oh, okay. Okay, so again, these two graphs are representing two different ideas. They're both based off the same river. One's talking about how deep it is. One's talking about how fast or how far they went. Okay? So, distance in feet, this whole distance here, if I get up to this point right here, this would say at a certain time, they went a certain distance. And I think that says 10,000 there, doesn't it? Holy cow. All right, so I'm actually going to draw this graph on the next slide just so I have room. Okay? So it says use the graph that Maria did, and we're going to answer all the same things. Okay? So this started at 0, and this time right here, that's time, was 60, 70, 80, 90, 100, 10, 20. So my domain on this particular problem goes from 0 to 120. And remember, the domain are the x values. The range is the goofy one. That's the one that we mainly use the y values. So again, my range started here at 0, and it went up to this point right here. So 2,000, 3,000, 4,000, 5,000, 6, 7, all right, 2, 4, 6, 8, 10, 12, 14, 16. So that's like 16,000. So our range goes from 0 to 16,000. Okay, again, we're using the same river to read two different things. The depth of the river for the first one, the distance was traveled for the second one. And then it says the maximum. Well, this is the maximum right here. And then the minimum is right here. Okay? Increasing. So take a look at this graph. Is it going up the whole time? Is it increasing the entire time? Sometimes it's a little steeper, but it never goes to a downward motion. So it's increasing from 0 all the way to, what did we say this was? 120? Decreasing. Does this graph ever go down? No. The official math term is nope. Is it really the official math term? In the land of stirrup, it is. Okay. And then we want the x-intercept. And yeah.
For maximum, do you always go from like the highest x and then the highest y?
Yeah. So for right now, we're making it a point. So this point right here is the highest, so 120 comma 16,000. So right now we're saying it's a point.
Is that how it always be though?
For right now. It's an easy error to correct later, but for right now I'm just trying to get you to realize there's a point that happens to take place. We'll be able to correct it in the near future, and I'm not too worried about it. Okay, x-intercept, y-intercept. X-intercept, y-intercept. Is that the x-intercept? Is that the y-intercept? They're both 0. The x-intercept is at 0, 0. The y-intercept is at 0, 0. That's all it is. It's kind of a weird situation, but yeah. Yeah. All right. Another question? Yeah.
I was wondering for this one, the depth of the river one, so we don't have a
X-intercept. It doesn't cross the x-intercept at all. Yeah, if it touched
So
down
we
here.
just can read that one.
Yeah, so being it touches that, that's the y-intercept. But this one, the reason it works is that they're both at 0 and 0. 0, 0 is the origin, which is where the x-intercept and the y-intercept meet.
Okay.
Cool? All right. So looking at the backside, it says Sierra looked at the data collected by her 2 friends, made several of her own observations. Explain whether you agree or disagree. Okay. The depth of the water increases and decreases through the whole river. So she says the depth of water increases and decreases through the 120 minutes. Well, that's the depth of the river. Does it get deeper and shallow and deep and shallow and deep and shallow type of thing? So I think this one has to be I agree. I agree. And then you could say you agree. The reason you agree is you could say increasing and decreasing throughout the graph or something like that. Or just put I and D on graph. Does that make sense? And then she says, for letter B, the distance traveled, so now we're on this one, the difference traveled is always increasing. Well, this is time, this is distance, right? I guess I forgot to write that. That's distance. So this is going up the whole time, though it slows a little bit, right? But I would say the distance traveled is always increasing. I would also agree with that. The reason you say that, entire graph is increasing. Okay? So we're having a further and further distance as we float down the river. Oh. Letter C. The distance traveled is a function of time. The distance traveled is a function of time. So, first off, we know this is a function. Why do we know this is a function? Say vertical lines. Yeah, I could draw a whole bunch of vertical lines on here, and it would only cross it once. So I would say the distance traveled is a function of time. It is a function. Time is definitely on the x-axis. I like it. Okay? Vertical line test passes. And then letter D says the distance traveled is greatest during the last 10 minutes of the trip than any other 10-minute interval of time. Okay. So she's saying basically this is the fastest amount, but I think this, I have to disagree because I think there's other parts of the trip have the same steepness, and the steepness factor is basically how fast you would be going. Okay, so I don't think the last 10 minutes is the fastest part of the trip. It might be fast, but it doesn't have to be fast. It'd be like if you were to drive from here in a car to your home, you're gonna, you might get up to 45 miles an hour, but then you would slow down, and then you get up to 45 miles an hour, and then you would slow down because you have lights and traffic and people on the road, right? Yeah. Okay. So, yeah, that's kind of that. So the one distance is great. I disagree. The reason I disagree on this one is because there's other parts that are just as steep on our graph. Okay? The y-intercept of the depth of water over time is 0, 0. The y-intercept, that's a definite disagree because this is actually a 0.04. We got into the river as 4 feet. Okay, so disagree. So disagree with the depth of water. The y-intercept of the depth of water over time is 0, 0. No, because on that graph it was 0, 4. You got into the river as 4 feet deep. Then it says the distance traveled increases and decreases over time. Okay, so if we go to this graph, it says the distance traveled increases and decreases over time. Well, I slowed my rate flowing down the river, but I don't go back up the stream, right? I didn't like row backwards or something, did I? So I disagree because I never go backwards. I just keep going forwards down the river. And then it says the depth of the water is never 11 feet. Well, what's the deepest this water is? It's kind of pink. So the top right, it's circled. Well, how deep is this river? 12 feet. What was the shallowest the river was? 4. So is 11 between 4 and 12? So do you think this river could have been 11 feet deep? Yep, I agree. The range of the distance/time graph, distance/time, so that's this graph, is from 0 to 15,000. Well, I have it from 0 to 16,000. Right? Because this got up to 16,000 as far as when I look at the graph. So I disagree with letter H. I think because we went to 16,000. We didn't go to 15,000. The domain and the depth of the water with respect to time is 0 to 120. Yeah. G. So it's 4 from 4 feet to 12 feet. Is 11 in between 4 and 12 somewhere? So yeah, that river could have gotten to 11 feet deep. Absolutely. So the domain with both, the domain of the depth of water, yeah, I think 0 to 120 is correct. We wrote the domain 0 to 120. It was the same amount of time. Just because one person was checking how deep it was and someone was tracking how far we were going, we still did 120 minutes, 2-hour float down the river. The range of the depth of water over time, the range of the depth of water over time is from 4 to 5. Well, friends, we found the range of the depth of water from 4 to 12, so I don't agree with that one. The distance/time graph has no maximum value. No. Don't we have a max? Because after 2 hours, we got out of the water, right? We traveled 16,000 feet, about 3 miles. So I don't think, we chose to get out of the river at 120 at 16,000 feet that we traveled, horizontal traveled a bit. So I don't think that's right. And then the depth of the water reached a maximum at 30 minutes. 30 minutes. So here's our maximum, yes? Here's 30 minutes. Is this point right here higher than this point right here? Is this point right here vertically higher than this point right here? So I disagree with that. You have a higher point later on. Okay. All right. We okay so far? What's today? Thursday? Wednesday. Wednesday. It's really Thursday? No kidding? Wow, I just lost a day. Yep. Hey,